Okay, now let's look at example 6. A ball of mass 0.15 kg is attached to one end of a string 0.6 meter long. The ball makes 2 revolutions per second in a horizontal circle. Calculate the centripetal acceleration of the ball and the magnitude of the tension in the string. Okay, so this example 6 is the same as example 4. Okay, tetapi kita tambah satu, which is we want to find the magnitude of the tension. Okay, sama juga macam example 4 yang tadi. Okay, what we have here, we have the mass and then we have the radius. So this one is the length of the string kan. So benda ni samalah dengan radius 0.6 and this one here is the frequency. So just follow saja step dekat example 4, which is AC is equal to V square divided by R. Tetapi kita kena cari dahulu V, which is in terms of frequency, which is 2 pi F times with the radius. So kamu akan dapat 7.54 meter per second dan masukkan dekat sini. So this one Miss tidak perlu ulang panjang lagi. Benda yang sama dekat example 4. So kamu boleh rujuk balik video example 4. Okay, divided by 0.6, which is sama dengan 94.75 meter per second. Okay, so now kita akan fokus kepada soalan B, which is the magnitude of the tension. Okay. So here, dekat mana kita punya tension tu adalah dekat string here, dekat sini. So what we have here is the ball and we have a string. So remember, we will have the string away from the object. So this is the string away from the object. Dan kita tahu juga acceleration, the centripetal acceleration, the direction is always towards the center. Okay, towards the center. This one here, AC, will always towards the center. So, dekat horizontal axis, kita hanya ada satu saja, which is tension. So, how do we find this tension? Kena resolve, which is the sum of Fx equal to MAC. Since kita punya acceleration juga adalah dekat x-axis. So, mesti sama dengan MAC. Bermaksud dekat sini, tension. Okay, tension, dia follow direction of AC. So, dia adalah positive. So, remember, okay, follow acceleration positive, opposite acceleration negative. So, T ni, dia ke kanan kan? Which is sama direction dengan AC. So, dia adalah positive. So, here, kamu just masukkan di mana mass adalah sama dengan 0.15 and acceleration yang kita sudah dapat tadi. So you will get the tension is equal to 14.21 Newton. Okay, next one, example 7. A sphere of mass 5 kg is tied to a string. It moves in a vertical circle of radius 0.55 meter at a constant speed of 3 meter per second. Determine the tension of the string at points A, D, and E. Okay, so we are given a figure here to help us understand the situation. Okay, so we have sphere which is connected at the end of a string. So this sphere, okay, will move in a vertical circle. So in this circular motion, and at each point, okay, at each point we need to find what is the tension of the string here. Okay, so we are given the mass of the sphere 5 kg and then the radius of the circle, which is, this one is the radius 0.55 meter and the speed 3 meter per second. Okay, let's write this down. We have mass 5 kg and then we have radius 0.55 meter and then we have the velocity 3 meter per second. And then at each point, we need to find the tension. Okay, so how can we find the tension? Okay, remember tension here is a force. Okay, tension is a type of force. Bermaksud kita akan keluarkan formula untuk force. Okay, so force dekat sini, it's either on the x-axis ataupun y-axis depending on the point here. Okay, kita tengok point A dahulu. Okay, dekat point A dekat sini, okay, kita akan ada tension. Kita tahu ni adalah string kan. So string, this one is the string, this one is also the string. So kita tahu string ni adalah along the y-axis. Along the y-axis. So let's lukis free body diagram untuk y-axis saja. So kita ada ke bawah adalah tension. Okay, ke bawah adalah tension, but since this one is a sphere with a mass, so kalau ada mass akan ada juga weight force, which is always going downward. So kita akan ada weight force juga. So weight force going downward, di mana weight force adalah mg. So kita ada tension ke bawah dan juga weight force. Okay, dan kita tahu centripetal acceleration, okay, direction dia adalah always towards the center. So bermaksud ke bawah juga. Okay, centripetal acceleration tu adalah along the y-axis and it is going downward. So in order to find the tension force, okay, keluarkan formula. The sum of Fy is equal to MAC. Sebab dekat y-axis kita ada acceleration. So kalau follow acceleration dia akan jadi positif. So kedua-dua ni follow acceleration, so bermaksud T dan mg adalah positif. T plus mg sama dengan MAC. Okay, so since formula, okay, not formula, the information that we have adalah in terms of velocity. Okay, kita tiada acceleration. So in terms of velocity, kita terus masukkan, ubah kepada this one. Okay, kita tahu acceleration adalah sama dengan v square divided by r. So dekat sini teruslah ubah kepada v square divided by r. So kita boleh cari value for the tension. So masukkan semua information yang kita ada, which is mass and then gravity equal to mass, velocity still sama, divided by radius. Okay, don't forget the square here, and then the radius. So you will get the tension at point A is equal to 32.77 Newton. Okay, so that one is for point A. Now kita akan tengok dekat point D. Okay, dekat point D here. Okay, step yang sama, kita akan lukis free body diagram. Okay, but now kita punya tension adalah along the x-axis. So along the x-axis here. So to the left. So to the left is the tension and also the centripetal acceleration. So centripetal acceleration is also to the left. Okay, tetapi kita tahu juga dia akan ada mg, dia akan ada weight force going downward. So kita lukis juga this one. Okay, walaupun kita tidak akan gunakan dalam formula untuk cari T. Okay, sebab T only on the x-axis. Okay, so just guna Fx is equal to MAC. So now tension will be equal to mv square divided by r. Okay, terus gunakan this one lah. Sebab kita ada information untuk velocity. Okay, so because tension is only on x-axis. So dekat x-axis kita hanya ada tension saja. Tidak any other forces. And then you will just masukkan here V3 square divided by radius, yang lain still sama. So tension at point D is equal to 81.82 Newton. Okay, so that one is point D. Now point E. Dekat point E, sama juga steps dia. Kita akan lukis free body diagram di mana tension is along the y-axis. So tension is towards the center. And then ke bawah kita akan ada NG. So lukis dekat sini point E. Okay, point E tadi ke bawah always mg, which is the weight force, and then tension tadi towards the center. Okay, this one here. So tension ni tadi kan, tadi mesti away from the object. So that's why dia towards the center. And centripetal acceleration juga always towards the center. So here lukis di anak panah untuk AC. So bolehlah keluarkan. So the sum of Fy is equal to MAC. Okay, follow AC positive, opposite will be negative. So T will be positive, Mg will be negative. Sama dengan mv square divided by R. And then just masukkan, di mana mass adalah sama juga. Okay, dan tekan calculator, kamu akan dapat value untuk T dekat point E adalah sama dengan 130.87 Newton.